Hello, welcome back. In this lecture, we're going to discuss some of the basic operators supported by the C programming language. So operators, again, just special symbols for functions. You're performing some kind of operation. So we're going to discuss basically in this lecture 4 different types of operators: the arithmetic, logical, assignment, and relational operators. And then we're going to discuss in another lecture the bitwise operators, and then a couple other special operators that don't really look like they be an operator, but they are. The size of operator and the casting operator. So an arithmetic operator is probably the most common sense one, the one that you're probably most familiar with. It's a mathematical function. It takes 2 operands and performs a calculation on them. It's infix, so it's the operators in between the operands. A logical operator, sometimes called a Boolean operator, is an operator that returns a Boolean result, true or false value. That's what a Boolean is. So it's really just a conditional operator. It's based on the Boolean result of one or two other expressions. One or two other expressions. An assignment operator just sets variables equal to values. It assigns the value of the expression at its right to the variable at its left. So it's a right operand and a left operand. Again, it's infix. And then a relational operator will compare variables against each other. So this is kind of comparable type operator, less than and greater than. But let's go over each one of them because there's many of the different operators. C supports a super rich set. So the first ones are these arithmetic operators in C. Okay, these are the mathematical functions. So here's a little table that I found online for from tutorials, the tutorials points website, which is nice. And this summarizes all of the arithmetic operators in C that are supported. So the basic ones, just like in math, there's nothing really new here. On the left-hand side of the table is the operator, and the middle is a description of what it does, and then on the right is an example. Right, so plus, the plus symbol, that's going to add 2 operands. It's infix, it's in between the 2 operands. So what you would do is you could either add variables, you could add a combination of constants in a variable, or just constants. In this one, we're saying a plus b equals 30. But the actual operator and operands are just a plus b. And then that would be the example. Minus subtracts 2 operands, a minus b. So a minus b could actually be equal to something like a negative 10 if a is equal to 20 and b is equal to 10, or b is equal to a negative 10. Is that right? 20 minus negative 10, yeah. Asterisk is for multiplication. Again, infix in between operators, in between operands. Division is the /. Percent is modulus operator. This is the remainder operator. So if you were to say like a variable percent a, what is that going to be equal? If b was equal to 20, a was equal to 12, the modulus operator would return 8 because that's the remainder of 20 divided by 12. Plus and minus, these are specific incrementation and decrementation operators. They're still referred to as arithmetic operators, but you typically only see them you'll see them mostly in loops when you repeat code, but not always. I mean, in this example here, you're incrementing a variable by 1 or by a specific value if you're doing something else. But so if you do a++, it's just whatever a was. If it was 5, it's now going to be equal to 6. And then there's a decrement operator, which decreases the integer value by 1. So a minus minus. And the plus and the minus, you should notice, are after the variable. This is referred to as postfix. And what this means is if that variable is in an expression, it's actually not going to be assigned the extra 1 until after that statement. If it's prefix, it'll be assigned before it. So let's go through some examples of these arithmetic operators and code blocks so that they make a little more sense. So here's code blocks. Here's our main routine. We're familiar with this by now. I'm just going to create a couple variables and do some operations on them and then print them out. And I'm just going to create integers. There's going to be, and it doesn't matter though. You could create floats to do calculations or doubles, but we'll just make it basic. We'll say a is equal to 33. We'll create another variable of type integer, and we're going to assign that to 15. So we're doing a declaration and an assignment on a single statement, and then we're just going to have a result variable, and this is going to be initialized to 0. So here we can start performing calculations. We can say C, and we can do assignments. We haven't learned about assignments specifically, formally, but we know what assignments are. Assignments are taking data and putting that data in that variable. So C equals is taking whatever is on the right-hand side and putting the result into that variable. So if we say A plus B, again, this just looks like normal mathematical routine. And it is. It would just be 33 plus 15, and what would be the value of C? 48. And so you could just print out the values, right? You could just say C is %D, using our format specifier and just printing out C. And then maybe we could do a line feed. And that would just add two numbers. It's that basic. It's that simple. We're just displaying it. So when we run this program, we're going to see the addition of 33 plus 15. This is still running an old one. Make sure we recompile this, save it, save build, and then save run. Let's make sure that we don't have anything up because it's still, yep. Because I have an undeclared identifier. I have a compiler error. I said C instead of result. Didn't make sense. Sorry about that. Now when I build and I run, it's going to run my new program. Make sure. Oh, we still have an error. Result set. No, let's see. We're still using C. Wow, a little careless. There we go. Now I don't think we'll have any errors. Now we build. No errors. So now I can run it. And you'll see that when I run it, after my virus scanner, it says C is 48. So you can play around with these. I mean, these are basic, right? So A plus B, you can do the minus. You can do the asterisk for multiplication. And then you can do the division for /. And then the % symbol, which is modulus. So this is interesting because, 33 divided by 15 would be 2 with a remainder of 3. So result is going to be 3 in this case. Let's just make sure, though. Save this and make sure we close our execution. And when we run it, we can see that we have C is equal to 3 because that's the remainder. Otherwise, it's pretty basic. The important ones with the plus plus are that to understand the prefix and the postfix. So if I were to say, and this is more relevant when you actually do it in a single statement, printf. So let's say I print out A++. What that's going to print out is 34 because you're going to increment A by 1 and then print it out. But you're going to do it in the single statement. You're going to do it in the same line because it's afterwards. So actually what's going to be displayed here is it's only going to display 33. It's not going to actually increment A until the next line of code. So if we run this, you'll see it just prints out 33. Right? Now, that's the difference between doing a plus plus A. If you do a plus plus A, which is the same thing, you're going to increment by 1. Difference here, though, is you're going to increment it by 1 and then before the statement is executed. So here now, we'll notice that we just have a couple warnings, no errors. And when we run it, now you'll see the answer is 34 because it's actually incremented before the statement is executed. And that's important to know between plus plus variable name versus variable name plus plus. That's just referred to as prefix and postfix. Right? The same would happen for the minus minus. So keep those in mind for your unary. These are also unary operators because they only have one operand. The other ones are binary operators because they have an operator in between the operands. But understand the minus minus versus the plus plus, and then also understand if you place it before the variable or after the variable, when it's going to actually increment or decrement. And again, all it is if it's after the variable, it increments or decrements right there before it executes the line of code. If it's before the variable, it's going to execute the line of code, and then after that's executed, the statement, it's then going to either increment or decrement. But play around with this. Open up a window, do a bunch of different arithmetic expressions, and see how it all works. Now let's talk about some of the other types of operators. The next group of operators are referred to as logical operators. Right? And we defined what this means is it basically is conditional type operators. They return Boolean results, true or false values. So the symbols that represent logical operators are the ampersand, ampersand, the two parallel bars, and the exclamation point. The ampersand is called a logical AND operator. And it says it's also an infix operator that takes two operands, one on the left, one on the side. Basically, if each operand is non-zero, then the condition becomes true. And so non-zero means 1, which means true. So if A is true and B is true, then the answer would be true. If A is false and B is true, the answer is false. If A is false and B is false, the answer is true. Right? Or false, because they have to both be true. Sorry, I was getting confused with the or and other ones. So again, we'll do some examples of that. And then parallel bars are the logical OR operator. Again, this should be similar to your math class, so I don't want to spend too much time on it. But if any of the two operands is non-zero, if either one is true, then it's true. So if A is true and B is false, it's true. And that's, remember, these are expressions that return values. So the return would be, if A is true and B is false, the return would be true. And then the logical NOT operator, which is the exclamation point, this just reverses the logical state of its operand. So if the condition is true, it then is going to return false. So if you say not A with the exclamation point and A was true, A is false. If you put the not outside of parentheses, whatever A and B evaluated to, it's now going to evaluate to the opposite. So let's again look at some examples and code blocks. Okay, here's code blocks. And again, I'm going to create a couple of variables to demonstrate logical operators. Again, I'll just create some integers. We'll say A equals 12, and then B equals 20. And then int. Actually, what will be better is we'll create a, because I don't want to utilize conditions. So we'll just create a underscore bool, and we'll assign that. I will say that will be result, and we'll initially not assign that to anything. And then we're going to just print out some data. So we want to see what the values are of these expressions returned if we use the logical operators. So in here, I'm going to print out %d, which is an integer, because remember, Boolean expressions are just integers. Boolean variables are integers. So if the Boolean value is 1, then that means it's true. If it's anything else, it's non-zero. Or if it's 0, it's false. Anything else, usually 1, it's true. So I'm just going to print out the result. And then I'm going to assign some data to it. So if I say result equals A and B, now that's not going to make any sense because these are numbers. So let's initialize A equal to true, and again use Booleans. And here we'll say this is true, and this is true. Right? And when we use the ampersands, this is saying A and B both have to be true in order for the return to be true. So results should print out 1 because 1 represents true. So let's build this and make sure that we have to use the right namespace. So we're just going to represent 1 for true and 1 because we don't do in the right include right now, so that's no big deal. So now when we run, it should report true, 1. And it does, 1. Now if I change any of these to not true, if I say 0, then the result is going to be false because A and B both have to be true in order for the result to be true. Right? So if I build this and I run it, you're going to see that the result is 0 because it's false. So either one, if I changed A or B to 0, which means false, the result would be false because both A and B have to be true. Now if I say A parallel bar, which is or A or B, only one of them has to be true in order for the result to be true. So in this case, result should be 1. So let's build this and run it. And now we have a value of 1. 1. So only one of them has to be true. So now if I make them both false, and this is going to be much more applicable when we talk about if statements and conditionals and making decisions, but I am demonstrating Boolean logic here. Now both are false, so this should return 0, which is false, and it does. 0. So pretty neat. And then the last one is just the not symbol, which is the exclamation point, which just does the inverse. So if I say not A, if A is equal to 0, A is now going to be equal to 1, or result will be. And result is going to be equal to 1, which it is. So those are the three logical operators. Again, they'll be used in usually decision statements. Let's now move on and talk about another set of operators. Now here are the assignment operators. We're pretty familiar with at least the simple assignment operator, which is the equal symbol. The equal symbol assigns data, and that's pretty basic. C equals A plus B. C is going to be the result of A plus B. Now there's these compound type of operators where you can do plus equals, or minus equals, or star equals. Plus equals is where you add and the assignment operator. So it adds the right operand to the left operand, and then it assigns the results to the left operand. So you could say C plus equals A, and that's the same as saying C equals C plus A. Minus equals the exact same thing, except you're subtracting, and then you're assigning. So you subtract the right operand from the left operand and then assign the data. So if you say C minus equals A, it's really C equals C minus A. It's kind of a shorthand notation, these plus equals and minus equals. You can write things a little faster because you do two operations essentially in one single statement. And then multiply is the same thing, star equals, multiply and assign. So C star equals A is equivalent to C equals C times A. It's pretty straightforward, I think. The other assignment operators are similar, except you're using division. So division equals is divide and then assign. Percent is do the modulus and then assign the result. So those are pretty straightforward. And then we have some other ones which we're going to talk about in another lecture in more detail. So I'm not going to touch them on here because they're really completely different. They're called bitwise operators, which is left. And all I'm saying here is that for those bitwise operators that we're going to talk about, you can also assign them in single statements. So shifting, doing a left shift and a right shift, and assigning, you can just do less than equals and write that right greater than equals. And then again, the ampersand, the caret, and the parallel bar are all related to doing things on bits. So we'll come back to that, but they are part of the assignment operators. So the assignment operators just pretty easy, right? Assigning data, and then if you want to actually do expressions, a couple expressions, then assign it, you do the combination ones. The relational operators are comparison operators. They compare two values. So this is important. Equals equals will compare the value of two variables. And if they're the same, it's going to return true, because it's going to return a Boolean expression, true or false, or a Boolean value. Exclamation point equals is checking if the values of two operands are equal or not. Right? So A is not equal to B is how you want to read that. If A is true and B is true, then that's going to return false because they're equal. So A would have to be false or B would have to be true, or vice versa, and that would return true. The greater than symbol is checking whether or not A is greater than B. Less than symbol, A is less than B. Greater than equals, A is greater than or equal, and less than equal. So again, this is all basic math stuff. I'm not going to go through examples in the ID because this is pretty straightforward. Comparison operators, just like in math, greater than equals, and so forth. So hopefully we have a good handle on the basic operators, arithmetic, logic, assignment, and relational. Used quite a bit, so you need to understand them. Hopefully it's not too difficult or confusing. You're going to use a lot of this in if statements and decision statements, so we'll be providing a ton more examples on these. Thank you.